It's a new day on SpaceX Daily, episode 39. It's July 21st, 2026, and I'm Patrick in Vancouver. From the launch pad to the trading floor, here's everything that moved today. Vandenberg's 50th launch of 2026 shows Falcon 9 reuse sustaining cadence while Starship readies its next V3 test flight. Remember the Falcon cadence discussion from yesterday. The Western Range at Vandenberg Space Force Base supported its 50th launch of 2026 today, marking the site's busiest year on record for orbital missions. SpaceX flew its 50th orbital mission of the year from the California site on a Falcon 9, carrying another batch of Starlink satellites from SLC-4E. The same booster lifted off successfully after a last-second engine start abort the previous day, and had already completed 22 prior flights. Ground operations coordinated multiple vehicles and payloads through shared infrastructure, while range crews maintained full safety and telemetry coverage. Recovery teams tracked the first stage landing on the drone ship and collected the payload fairings for later reuse. That rapid turnaround on existing hardware moves the open question of annual launch rate ceiling forward by demonstrating sustained tempo without new range assets. From Falcon reuse on the ground, the next vehicle applies the same reuse logic at higher altitudes. Starship last appeared here yesterday. SpaceX is preparing the next V3 integrated test flight after the recent countdown abort. The vehicle now carries upgraded tankage, avionics, and thermal protection aimed at higher payload capacity. Ground teams reviewed data from the prior attempt and set a July 23rd target window that will collect fresh heat shield performance and engine throttling measurements. The flight profile continues the program's iterative approach to flight software and structural changes ahead of orbital refueling demonstrations later this year. This test moves the open question of full and rapid reuse cadence forward by validating the V3 hardware changes in flight. While Starship iterates in Texas, another Falcon payload demonstrates immediate on-orbit utility. A Falcon 9 is scheduled to carry Northrop Grumman's first two-armed satellite servicing spacecraft on an upcoming mission. The dual manipulator system is designed to capture and service legacy satellites that lack dedicated servicing ports. Mission planners expect the demonstration to validate capture sequences and tool use operations in microgravity for the first time. Success would directly extend the operational life of existing on-orbit assets without requiring new satellite builds. Servicing existing satellites pairs naturally with delivering new crews to the station. NASA has scheduled briefings for the Crew 13 Dragon mission planned for September. The flight will rotate crew members to the International Space Station, deliver new science payloads, and return samples from prior expeditions. Training for the mission incorporates lessons from earlier Dragon flights to refine rendezvous procedures. Dragon operations continue their steady crew and cargo rotation cadence that supports both NASA and commercial station needs. While Dragon supports people in orbit, Starlink expands connectivity on the ground. Starlink has begun offering residential and commercial service in Seychelles after regulatory approval and gateway installation. Terminals are now available for immediate activation in previously underserved island areas using existing satellite passes. The rollout delivers low-latency links without requiring additional orbital assets or constellation changes. Starlink's terrestrial growth sits alongside the larger Musk compute buildout. Cursor reported that pairing a high-performance planner model with a low-cost executor model reduced large project inference costs by roughly 1/8. The same agents rebuilt Isicle per Polygon from scratch and passed the complete test suite without any human-written code. Elon Musk stated that SpaceX engineering data will feed the next 2 trillion parameter Grok training run. Researchers also published a sandbox bypass that affects Cursor, Codex, and Gemini CLI through crafted inputs. Observers on X noted the rapid Falcon 9 turnaround between the abort and the successful 50th Vandenberg launch the next day. Several accounts highlighted the booster's steadily climbing reuse count, while community members shared coastal photos of the Starlink deployment plume. One thread discussed how the Northrop Grumman robot arms could extend satellite life once demonstrated on orbit. Worth keeping an eye on, Musk's data center project faces accusations of bypassing clean air regulations in multiple states. Reports cite installation of unpermitted turbines to meet power demand, and regulators are reviewing whether facilities violated permitting timelines before operations began. Resolution would require either retroactive approvals or operational adjustments. On the AI front, the planner-executor split and SpaceX data feeding the next Grok run show how the compute thread continues to draw directly from flight hardware experience. The engineering angle here starts with the raw cost of silicon, electricity, and training tokens that produced the cursor agents. That floor sits at a tiny fraction of the engineering hours once required to write and debug an equivalent database engine from scratch. The idiot index measures the multiplier between that token and watt floor and the delivered working code. Each successful test suite pass collapses the multiplier by removing human review loops. Because the planner selects architecture while the cheaper executor writes the implementation, the system trades a modest increase in planning tokens for an 8-fold reduction in total inference spend. That trade-off holds only when the planner's higher capability steers the executor away from dead-end paths, an assumption now validated on a non-trivial code base. The next measurable step is whether the same split scales to larger safety-critical systems where verification cost dominates. If the pattern holds, the engineering bottleneck shifts from writing code to specifying requirements and running exhaustive tests, exactly the constraint SpaceX already faces when scaling Raptor production or Starship flight software. Cursor's planner-executor split mirrors the division between Starship's flight computers and ground test stands, where high-fidelity simulation runs on expensive hardware while lower-fidelity checks run on commodity clusters. In both domains, the goal is to drive the idiot index toward 1 by letting raw compute replace repeated human iteration. Continued measurement of token cost versus delivered functionality will show how quickly that gap narrows, just as repeated hardware reuse already compresses marginal cost per flight. And a quick market note, SPCX closed at $127.67, up 6.1%. Before we go, watch for the July 23rd Starship V3 window and any fresh heat shield data it may return. That covers everything worth knowing about SpaceX today. SPCX is trading at $127.67, up 6.1%. A quick rating on Apple Podcasts or Spotify goes a long way. I'm Patrick in Vancouver. See you tomorrow. This show comes to you from the NARA network. If you want another sharp daily briefing, Tesla Shorts Time has you covered, your daily deep dive into everything Tesla. All our shows are free at naranetwork.com. New to the network, naranetwork.com/start-here picks the right daily briefing for you in about 2 minutes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.